Good evening. Today we will discuss some leftover questions for the assignments. See, we have been given a auto transformer with the parameters as the input side voltage is 5 kV, number of turns in N1 is 1600, number of turns in N2 is N2 is 400 and number of turns in N3 is 200. So and Z2 is connected to a 90 plus J60 resistive plus inductive load, and Z3 is 200 kilowatt purely resistive load. So they have asked us to estimate the primary current in which is entering. Okay, what we need to do, the total number of turns in N1 is 1600, and if we count the total number of turns in entire winding N2 plus N3 is N2 plus N3, that is 400 plus 200, that is 600. So also if we want to find out that voltage which is induced across Z2, that can be found out by the transformer turns ratio formula. So input voltage is 5 kV, output voltage can be found out by the turns ratio formula, that is 1 to 50. Now they have now we need to find the power consumed by load Z2. What is the power consumed by load Z2? Load Z2 has been 90 plus J60 ohms. So we will find out the power consumed, that will be V square by Z2, mod V square by Z2. So it comes out to be something 14.445 at an angle minus 33.6 degrees. So if we make that input power plus input power equal to output power, from there we can get the total power which is input. So 14.445 is total kVA consumed by this load Z2, and load Z3 is consuming 200 kVA or kilowatt, since it is resistive load. So total kVA consumed at the secondary side is 214.445. So by the formula, single phase kVA will be root that is VL IL, which is equal to 214.445 kVA. Now to calculate the IL, will simply divide by VL, that is 500 volt, and we will get the IL as 49.9 ampere, sorry, 42.9 amperes. Now they have asked estimate the input power in kilowatt. So this load, the load Z2 will consume, that this will consume real plus reactive power, both. Plus reactive power, both it will consume. Why it will consume both? Because both it is some combination of a resistive and inductive load. So we have found out the kVA of load Z2. kVA of load Z2 is 14.445, 14.445. So at an angle 36, from here we can segregate this as 14.44 cos theta plus sin theta. From, if we calculate 14.44 cos theta, that is around coming 12 kilowatt, and load Z3 is already consuming 200 kilowatt. So total input power in kilowatt will be power consumed by real power consumed by load Z2 and Z3. Z3 is consuming 200 watt, Z2 as now just we found out 12.03. So total power input to the transformer is that means the real power input to the transformer is 212.03 kilowatts. Okay. Now next question, we have a three phase transformer, that is 11 kV by 415 volt, three phase delta star transformer feeding a 10 kilowatt load. So, the load which is having 415 volt, three phase with efficiency of 75% and 0.75 power factor. So, minimum estimate the minimum kVA rating of the transformer. What we need to do, they have given a transformer, input voltage to the transformer is 11 kV, output voltage will be 415 volt. Now efficiency is 75% and power factor they have given as 0.75. So we will say that since efficiency is output power by input power, so S input is output kVA plus losses. So how will you calculate output kVA is? How will you calculate output kVA? This is 0.75 power factor they have mentioned. So output kVA will be kilowatt divided by kVA. This is kilowatt divided by the power factor. This is power factor. So what you get the kVA is 13.33 kVA output kVA. Now input kVA will, to find out the input kVA we need to divide by the efficiency, that is 75%. So once you divide the output power by efficiency, you will get input power as input kVA, apparent power input kVA is 17.78. Now input current can be written as root 3 VL IL, that is 17.78 kVA. So how will IL we will get by dividing by root 3 times 11 kVA, so that is 0.933 ampere. Now they have asked estimate the phase current in high voltage winding. Phase current in high voltage winding. So high voltage winding is 1100 kV1. So this is 1100. So we have already found out the line current. This is our line current. Line current is in 0.93 ampere. So in a delta winding, we know that phase current is related to the line current by this formula, that is phase current equal to line current by root 3. So simply we will divide by root 3 to get the phase current. Now they are asking estimate the line current in the low voltage side. Line current in the low voltage side. So we can use the formula for the transformation ratio to find out, since we know the phase winding current here, phase winding current is 0.538. So we can find out by the transformation ratio. What is the transformation ratio? This is phase voltage is 11 kV divided by the phase low voltage side phase voltage, that is 415 by root 3. And since the load current will be in since the current will be in inverse proportion to the turns ratio, we will apply this formula here. This is the turns ratio of the transformer. This is inversely related current. So you can find out the low voltage side line current as 24.4 ampere. Since it is a star connection, so phase current and the line current are the same. Since it is a star connection, as I told, that line current and phase current will be same. Okay. Now they have asked another question, similar track. This is consider a three-phase transformer. High voltage side is high voltage side voltage is 11 kV line to line. High voltage side line current is 25 ampere. Per phase turns ratio, they have given turns ratio this time. Estimate the low voltage side line to line voltage if transformer is star delta type. They have given that transformer is star delta type. So draw the transformer. We have drawn the transformer. This is star, this is delta. Now what can you do? They have given that high side voltage is, high voltage side voltage is 11 kV. This is 11 kV they have given line to line. Now if this is 11 kV line to line, so and they have also mentioned that high side line current is 25 amp. So again the turns ratio, you can apply the turns ratio. What will be the turns ratio? That is 1000 divided by root 3 VL. So this way you will be able to find out the low voltage side. There was estimate low voltage side line to line voltage. So through turns ratio we can voltages are related directly to the turns ratio. Turns ratio is ratio of phase voltages. So 11 kV by root 3, that is phase voltage in the star, divided by the low voltage side volt. This is related at 18:1. So low voltage side voltage is 352 volts. Now they was estimate the low voltage side line current. So again currents are in inverse ratio. We have line current, uh, phase current and line current same, that is 25 ampere in the star winding. So phase current in the delta winding I2, let us consider I2. So I1 by I2 will be inversely related, that is 1 by 18. Now I2, the phase winding current is I2, that is 440 ampere by from the turns ratio. Now if we want line current of this delta winding, we need to multiply by the factor of root 3, that will be root 3 times 450 amp, that is 779.42 amps. Now they have asked estimate the output kVA of the transformer. We have VLV with us, ILV with us. So output kVA will be root 3 VL IL. So that is 475.2 kVA. Clear? Now they are saying estimate est estimate the low voltage side line current in ampere for if the transformer is delta star. Now with the similar condition they have given that this transformer is now delta star. Earlier it was star delta. This is those similar conditions will apply. So first they have asked low voltage side line to line voltage. So line to line voltage is already towards the high voltage side is 11 kV. So apply the same principle, turns ratio is 18. So this is now phase voltage and line voltage in delta side are same. So 1000 divided by uh, VL, if I am considering line to line voltage at the low voltage side as VLV, that is star connected system. So that will be phase winding voltage will be VL by root 3. So this is directly related to the turns ratio, and you can find out the turns ratio is already mentioned. So VL by root 3 will be 1011 kV divided by 18 into root 3. So VLV we will get as 1058.74 volts. Now they are saying calculate low voltage side low voltage side line current. So we have star side current as 25 ampere, sorry, delta side current line current as 25 amperes. So we can apply the same formula. So phase current in the delta winding will be 25 by root 3, and phase current and the line current in the star winding are same, considered as IL. So root 25 by root 3 divided by IL will be equal to 1 by 18. So What is value of IL? Similarly, by the transformation ratio, we are getting 259.8 ampere. So kVA output of transformer. kVA output of transformer is simple, root 3 VL into IL. This is VL we have already found out, IL we have already found out. So just multiply these things to get value of output kVA of the transformer. Thank you very much.